Hello, welcome to my channel. In this lesson, we're going to learn how to remove factors from radicands, and this is an extension of the lesson which I already recorded before. Make sure you look at these examples. All right, so the first question here we can do is let's go ahead and find the square root of 75. So we know that 75 is not a perfect square number, so and then the 75 here is what you call the radicand. That's actually the radicand. Okay, and then this the entire thing will be a radical. Okay, but this one is like the square root, which is an example of a radical symbol. So to do this, we're just going to look at 75 and say, okay, now we have 75. So what can we do right here? So in 75, we can decompose, we're going to decompose or break down 75 into 5 times 3. Because I know 25 times 3 is 75, so I'm going to break it that way. So from there, since I'm looking for square root, I can already see that 5 and 5 repeat. And in order to find square roots, you have two numbers that repeat, and this is what you can do here. So you have, it's just like looking at square root of 25 times 3, right? So square root of 25 times 3. And what you can do is here, just break it down into 25, square root of 25 times square root of 3. And we know that the square root of 25 is 5, and then we just attach, just do this, and that's how you can remove that. Okay, let's talk about, say for example, we're looking for maybe number 2, looking at the square root of, let's say, 72, and then we have x to the 7th. And we're looking to remove factors from the radicand, so this is what we can do. We know that 72 is like 6 times 6 times 2. Because I know this is like a double of 36. So I'm going to do 6 times 6 times 2 or 72. And I know that x to the 7th is x to the 2nd and x to the 2nd, x to the 2nd, and x. So altogether you have 2 plus 2 plus 2 plus 1. That makes 7. So we're good. And this is what I'm going to do here. So I'm just going to go back to my radicand and just rewrite it to 6 times 6, which is 36, and then times 2, right? And then I'm going to look at x squared times x squared times x squared. So what I said in class is that students have to realize that the nth root here always divide the exponents, okay? So now we can rewrite this as x to the 6th times x, okay? And what I see here is I can actually find the square root of 36 to be 6, but the square root of 2 is still square root of 2. So that's a clean radical result. And x to the 6th, all you want to do here is for square root, so we know that there's a 2 here, okay? So you can say 6 divided by 2. This is one strategy you can use that. So you have to use this nth root, which is a second, to divide this exponent here. So they always divide themselves. That leaves you with x to the 3rd. And then you still have a single x here that did not escape from square root. So like that, this is what we're looking at in classroom, and I was explaining the quicker ways of getting your answer. So what you can do is just combine like terms. These are the numbers that are no longer in the square root that have been removed. So it will be 6 and x to the 3rd power, 6 and x to the 3rd power. And what you can do is to also combine these two, since they did not escape from the square root and you could not remove them, and the factors will multiply together to give square root of 2 times x, which is 2x. So this will be your final answer. Let's look at more examples. Suppose you have to look for the cube root of, say, negative 48 y to the, let's say, to the 8. Okay, I just wanted to just try out some random expressions and see what we can get out of that. I know that 48 is, I know I can decompose 48 in so many ways. So let me see if I can do 16 times 3. Or let me just do 2 times 2 times 2 times 2, as much as I can do. So I know that 2 times 2 times 2 is 8. And I know that 8 times 6 is 48. So that means I just have 6 left. So what I'm looking at is using the 3 to guide me. So I need 3 repeating copies of a number or of a factor. So I know there's going to be 8 times 6. So, and there's a negative here. This negative sign here, what I can do is to just distribute it for each copy. And I know that negative 2 times negative 2 is positive 4, and positive 4 times negative 2 is negative 8, and negative 8 times 6 is 48. So I don't have to decompose this any further, because if I do, it will not help me. So I need 3 repeating copies. And for this 8 here, what I can do here is I'm just going to look at decomposing this into y to the 6th, since I know that 3 divides 6, and then do the rest y to the 2. But this is going to be 2 plus 6, which is 8. So that's what I have. So this is what I'm going to do now. So it looks like I'm dealing with negative 8, the cube root of negative 8, because I know 2 times 2 times 2 is negative 8, times 6, then times y to the 6th, and times y to the 2nd power. So in this case now, I'm just going to take the cube root of negative 8, which we see here as negative 2 repeating. So that will be negative 2. And the 6 cannot escape because it's not a perfect cube number. So it will be 6. And then y to the 6th. For y to the 6th, it would escape. I can actually remove this from the radical sign by just doing 6 divided by 3, and it divides exactly. So it has to divide exactly too. So it would be y to the what? To the 2nd power, because 6 divided by 3 is 2. And y to the 2nd cannot be divided by 3 exactly. So it will just remain in the radical sign like that. It's y to the 2nd right there, like this one. And it still has the 33rd with that. And for 6, 6 does not escape. So since we have third root, so we also have 3 here. So now what we can do is to combine like terms. So this and this will combine. So combine both of them. And then we get negative 2y to the 2nd power. And these two guys did not escape, and we couldn't factor them out. So it will be cube root of 6y squared. That's how far we can go on this one. Okay, so there could be some more complicated problems, and we can keep addressing them as we see them like that. Okay, let's say for example you have a number, say um, cube, let's say square root of 108. Let's say let's say x to the 8, y to the 7th, like that. Let's go to example 4. Let's try it again quickly. So here I'm looking at 108, and I'm looking at what numbers multiply to give 108, and I'm looking at square root, and I know that square root here has a 2nd as the nth root. So this is what I'm going to do. So I'm going to break this 108 down. I know something has to relate to so let's break it down more. Let me see what I can do here. I know that I can do 2 times 54, and I know that 54 is 2 times 27, and I know that 27 is 3 times 3 times 3, right? Times 3. So this is what I can see here. So which means I can see some copies repeating. So you can see 2 repeats and 3 repeats. So there's something I could have done. I could have just done this as 2 times 2, which is 4, 3 times 3, which is 9, 4 times 9, that's 36, and 36 times 3 is actually 108. You see what I'm saying? So That's what we can do now. So with these numbers here, I can actually rewrite this as 36 times 3. Cool. So this is how you kind of break it down. Sometimes you might need to do that. So here it will be 36 times 3. What I'm doing here is I know that I can find the square root of 36, even if I cannot find the square root of 3. That will be okay for now. Then I'm going to 8. 8 can be divided by 2 completely, so I don't have to do anything. So it should be easy. For 7th, that's what I'm going to do. I'm going to break it down to y to the 6th and then y to the 1. That's how you get your 7th. So this is what I'm going to do now. So I am now going to finish it off like that. I'll say, what's the square root of 36? That's 6. What's the square root of 3? Well, it stays in the square root, cannot escape. What's the square root of y to the 6th? Then just do 6 divided by 2. That's how you find out. So it'll be y to the 3rd power. Notice that they are no longer in the square root, so these ones are escaping. So this is escaping. All right, so these ones are escaping from the radical sign. So what about y to the 1? Well, y to the 1. How can you find the square root of y to the 1? The 1 divided by 2 is not a whole number, so it stays back there like that. So the next thing you want to do is combine the numbers, the factors that were able to escape. So it will be 6y to the 3rd. And then you're going to combine the ones that could not get out of the radical sign. It will be square root of 3y. So this is how you would solve this problem. I hope this helps a little, and I will see you in the next lesson. Thank you very much.